For this presentation, I'm going to show how to find the scaling factor for the given network. So here I just given an example network. We are going to find the scaling factor for this one. So usually the scaling factor will be present in the beginning, right? So it is in the beginning of the checks of n and this adder. So now first we need to find the h of z. And for calculating that h of z, first I'm going to identify the equation from input to intermediate result. That is, I'm just selecting that intermediate result W of n is from S into X of n plus 0.509 W of n minus 1. So now if you are selecting an Z transform for this one, you will get W of Z is equal to S into X of Z plus 0.509 Z inverse W of Z. Now I'm selecting that W of Z is on one side. So minus 0.509 Z inverse W of Z is equal to S into X of Z. So now W of Z by X of Z is equal to S divided by 1 minus 0.509 Z inverse. Now we can choose that intermediate stage to output. Now the output is Y of n. It's a combination of W of n input. So now this Y of n is equal to 0.245 is a multiplier. Before that we have one adder this place. So the adder is adding W of n plus 0.245 W of n minus 1. So now again taking the Z transform even for this one. So Y of Z is equal to 0.245 W of Z plus 0.245 Z inverse W of Z. So now Y of Z equal to 0.245 W of Z plus 0.06 Z inverse W of Z. Now from this output by input Y of Z by W of Z is equal to 0.245 plus 0.06 Z inverse. For the transfer function h of z, we have the term y of z by w of z into w of z by x of z. So we know both the terms. I am just substituting the value 0.245 plus 0.06 z inverse. So this is for w of z by x of z. And so this is for y of z by x of z. And for w of z by x of z, that is s by S by 1 minus 0.509 Z inverse. So the transfer function h of Z is S into 0.245 plus 0.06 Z inverse divided by 1 minus 0.509 Z inverse. This is a representation. Now to identify the scaling factor, we have the formula. So S square is equal to 1 by I. This I is from the residue of 1 by denominator of Z inverse into Z inverse. So now I'm just representing the residue term only for the denominator, that is 1 minus 0.509 Z inverse into 1 minus 0.509 Z into Z inverse. Now if you are calculating the poles, we have got the poles at Z is equal to 0.509 and Z is equal to 1 by 0.509. But this value is greater than 1, so this is not calculating for the residue. So now we are going to find the residue only at Z is equal to 0.509. So that is equal to Z minus 0.509 into Z divided by Z minus 0.509 into 1 minus 0.509 Z into Z inverse. At that time, we are going to apply Z is equal to 0.509. So now this is equal to, I'm going to cancel these two terms. Now apply that Z is equal to 0.509 here. We'll get the term as 1.35 for this I. So now S square is equal to 1 divided by I, that is 1 divided by 1.35. This is equal to 0.74. Now S is equal to square root of this answer. You will get just 0.86. So to avoid that overflow, this particular network is initially multiplied with the scaling value of 0.86. That is going to be avoid the overflow limit cycle oscillation. Thank you.